So now that we've learned how to solve a system by graphing, I want to talk about how many solutions a linear system can have. So how many answers can we have to a systems problem like the one we've been seeing before? We kind of stopped right when we got our answer. We assumed there was just the one answer and we were done with the problem. But who's to say there can't be other answers out there? Why does there only have to be one? And in order to figure out how many solutions you've got going on, it really is helpful to picture graphs of lines. So if I graph two lines just on a little axis right here, I want to figure out, because every place they cross, when the lines cross, that's where the answer is. So how many places can two lines cross? That's kind of the question I'm going for right here. So if you draw two lines, they typically cross in just one spot. If those were my two lines, that would be my solution. If it was these two purple lines right here, that would be my solution. There's really not a situation where you're going to have a line, like if you were to have, where you have a line and then like two solutions where it crosses twice, that's not even a line for this one. So if you have a linear system where the equations are all lines, the first possibility is that we have exactly one solution. So, one possibility for a system is that we have just one answer. There's only one spot where the lines cross, and there's no other point out there that's going to work in our problem. So, with that being said, there are other possibilities. A second situation that you could come across where we don't have just one answer is thinking back to your geometry days. What if my two lines were like this? They kept going in that direction. Those lines are never, ever, ever going to cross. So in this situation, we actually have no solutions. If you have parallel lines, they're never going to cross, so there's not going to be an answer to the problem. And finally, there's one more situation out there. Let's say I had my first line. Maybe I had my line like this. And then I had my second line right on top of it. So my second line was like this. So they're right on top of each other. They're overlapping. This situation, you would have infinitely many solutions. Every point that's on one line works in the other. So there's an infinite number of points that work. Infinitely many solutions. These are called coinciding lines, by the way. Lines that are on top of each other like that are called coinciding lines. So if I get a system with two lines in it, there's only going to be one of these three possibilities. Either there's one answer, there's no answers at all, or there's infinitely many answers. You're never going to have a situation where there's exactly two answers. So, to close out this video, I have three different vocab words that I'd like to tell you about. Just kind of another way of referring to these three situations that you see before you here. The first example, when we have our problem right here where there's just one solution, that is called an independent system. So if we have just one answer, it's called an independent system. In a situation where we have no answers, like the parallel line problem right here, this is called an inconsistent system. And finally, a situation where you have infinitely many solutions is called a dependent system.